So in a smart glass project, this is the ultrasonic and the GSM module, which uses the Arduino Uno board over here. We can look that the ultrasonic sensor is connected over here, and the like audio feedback is given out using this particular speaker module. So what essentially happens is whenever there is an obstacle or object which comes in front of the ultrasonic sensor, based on the reflection of the ultrasonic waves, it computes the distance between them. So when it computes the distance and it figures out it is less than 30 centimeter, the Arduino board sends out the audio signal to the speaker using the DF mini player, where we have the program code and the stop, which is being the the command statement being sent out in an audio file. So whenever there is an obstacle entering in the 30 centimeter radius, so this ultrasonic sensor picks out the distance, gives it to the Arduino board, which is being, and then the DF mini player sends out the audio signal to the speaker, which is being given out as a stop command to the user to let them know that there is an obstacle around them. Also, when we look at the GSM module, this is the GSM module. So we have also added like emergency location sharing for the visually impaired users. So whenever they feel there is an emergency, by the press of a button over there, which is seen here, they can send the current location will be pinged to all their emergency contacts which have been predefined. So when we look at the next screenshot, so for example, when we have focus the um, Raspberry Pi on the camera setup, when we focus the camera setup on a particular image like this, or or something which is written over like this, we can clearly see that all the characters have been picked out over here. So even these characters will be given in the audio format in the Bluetooth Bluetooth headphones or the wired headphones we are provided. So all this character recognition is being converted to audio format using the Python text to speech library. So we can see the similar things here where we can detect the characters of each of the things. Now we move on to the object detection part where the camera system which is connected to the Raspberry Pi module and all the YOLO framework which has been running in the Raspberry Pi module picks up on what are the objects which has been in the neighborhood. So when it's able to detect that particular object, it gives out the audio output to the user that this object has been detected. So we'll see all these here. So this is the input thing that we have provided to our model. What the essential output looks like is there is a 500 rupee note, 200 rupee note, 100 rupee note. All this is provided to just to get the sense of how accurate our model is, how good it is able to pick up even when these notes aren't fully visible. It is able to clearly pick out the notes and let the user know. So in real life practices where you cannot just have each of the notes in front of the user, so it's kind of hard for them. So we are making it even so more accurate so that it is able to predict these nodes quite comfortably. That's another case of it right here. When we look at the since we are customizing it for a supermarket point of view, we are also ran it through the products over there. So we trained on a lot of products from groceries, from atta packets to for example these cool drinks, where they detect what the product is based on they can do both. We have trained them as objects, so they can do object recognition, or they can use character recognition to read out what the logo is or what it's been written on the can. So that's what we done. For the supermarket point of view, we have trained almost 150 products, which has been seen in daily supermarkets, and also we have trained it on fruits and vegetables so that the blind user can know what kind of food or vegetable it is. So that's it for the whole demo overview of the project. Thank you.